everyone. In today's lesson, we're going to talk more about completing the square. This time, we're going to do it when the a value is greater than 1. But before we can do that, I want to just recall one more time about completing the square when a equals 1. So I'm just going to do the first example with you, and then you're going to do the second one on your own. So first things first, we want to set it equal to the constant. So it looks like the constant is already here, so we're good to go for this example. So now we're going to go ahead and make our perfect square trinomial. So we have x squared plus 14x, and then we need to add a number to both sides of the equation. And the number that we add is going to be found by doing half of b and squaring it. So the b value is 14, so 14 divided by 2, this whole thing squared, should give me 14 divided by 2 is 7. 7 squared is 49. So this is the number that we're going to add to both sides of the equation. Okay, now we're going to factor this trinomial here. Now, because it's a perfect square trinomial, we know that we could write it as something squared. And remember that it's always this half piece that gives us the value that goes in here. So this is just x plus 7 squared. And then on the right side, all we have to do is add negative 97 plus 49, and that adds to a negative 48. So now we're going to solve, and remember we solve by taking the square root of both sides. On the left, the square and the square root cancel each other out, so we're just left with x plus 7 equals, on the right side we have a square root, so we need a plus or minus, and we're going to pop out the I, so this should be I rad 48. And then we're going to minus 7 on both sides, and we get x equals negative 7 plus or minus I rad 48. And don't forget that we have to simplify that radical. So if you break up 48 into good house, bad house, with the largest perfect square possible, it'll be 16 and 3, and the square root of 16 reduces to 4. So this final answer will be x equals negative 7 plus or minus 4i radical 3. Don't forget this I goes with that 4, so they're outside numbers, and then the radical 3 gets inside. And then that is my final answer. All right, why don't you guys try number 2 on your own, and then hit resume when you're ready for the answer. All right, here's the work. All right, if you need to pause the video, feel free to do so and take a look at the work. The first step's a little tricky as far as moving things over, but you want to make sure you have x's on one side, numbers on the other, half it and square it, add that to both sides, square root, solve, and simplify. So this should be your final answer. Okay, so now what I'd like to do is go over completing the square when a is greater than 1. So let's go through the steps just like we normally would, step by step. So we're going to set the equation equal to the constant. So equal to the constant. So if we take a look, this first problem is definitely set equal to the constant. Everything's good there. Step 2 is that x squared must have a coefficient of 1. And if it doesn't, we have to take out the leading coefficient of the x terms only. So take a look over here. The number in front of the x squared is 2, and it's supposed to be 1. So we're going to do exactly what the problem said. We're going to take out a GCF of just the number. So we're going to divide both pieces by 2. So by doing so, we get x squared plus 8x. And now our job is going to be to create that perfect square trinomial, except we're going to make the perfect square trinomial just on the stuff that's on the inside. So we're going to need to make some space. So we have 2x squared plus 8x plus some number. Now remember, whatever we do to one side, we have to do to the other. So let's do it. Let's take half of b and square it. So 8 divided by 2, right? 8 is your b value, and we're going to square it. So 8 divided by 2 is 4, and 4 squared is 16. So that's the number that gets added here to make that perfect square trinomial. But the only difference between this and the stuff that we did yesterday is that because we have this GCF out here, we actually have to multiply the 2 times the 16 and put that number here. So we're technically adding 32 to the right side because of this multiple that's out here, because 2 times 16, if I were to distribute it out, would actually be adding 32. So that's the main difference between yesterday and today. And then now we're really going to solve it the same as we did before. Here's my perfect square trinomial, and I want to factor it using the completing the square method. So I'm going to bring down the 2, and we want to write it as something squared. So remember, what goes in the parentheses here is always half of the middle term. So half of 8 gave us 4. So we can write this as x plus 4 squared. Then we add 32 and 8, and that gives us 40. And then we need to solve for x still. So before we can take the square root of both sides, we actually have to get rid of that 2 in front. So we're going to divide both sides by 2 first. So that will give me x plus 4 squared equals 20. And then we can square root both sides like we did yesterday. So x plus 4 equals plus or minus the square root of 20. Minus 4 on both sides, and we get x equals negative 4 plus or minus radical 20. And don't forget that 20 can be broken up into good house, bad house, 4 and 5, which makes 2 and radical 5. So my final answer is negative 4 plus or minus 2 radical 5. And that is my final answer. Now, if you wanted to fix the steps up here, you absolutely can. So step 3 says take half of b and square it, and then we're just going to add that number to both sides of the equation, or add that number to the left side of the equation. So be careful of what you add if there is a GCF to the right side. Okay, so that's what I mean here, is after we took half of b and squared it, we got 16, but be careful, we don't add 16, we add 2 times 16 over here. And then the rest is, like I said, solving like we did yesterday. All right, let's try another example. So here's an example where I have a GCF and an odd b value. So our first step is going to be to set it equal to the constant. So I need to move this 6x over here, and I need to move that 20 to the right side. So I'm going to go ahead and do that. So I have 2x squared minus 6x, and then if I move the positive 20 over, it becomes a negative 20. So same thing as before, we take out a GCF of just the number, which is 2, and I'm left with x squared minus 3x equals negative 20. Then I want to create that perfect square trinomial with all the stuff that's in the inside. So I want to take half of negative 3 and square it. But I can't divide negative 3 by 2 evenly, so I can just go ahead and square it. So remember, when I square it, I can square the top and square the bottom. So negative 3 squared is 9, and 2 squared is 4. So that's the number that I'm going to add to both sides of the equation. So I have 2, and then x squared minus 3x plus 9 over 4. And then I have negative 20 plus some value. Now remember, we're not going to multiply or add, we're not going to add the 9/4 to this side. We have to distribute the power, or the GCF, that's in front. So we have 2 times 9 over 4, and then that answer is going to go there. So in your calculators, go ahead and multiply 2 and 9/4. So 2 times 9/4. So all you're going to do is pause the video, type that in, and then hit resume when you're ready for the answer. Okay, so you should get 9 over 2. So that is what's going to get added to this side. And now we're going to factor like normal. So we have 2 Since it's a perfect square trinomial, we could write it as something squared. And remember, the number that goes in here is always the half value, which is right here. So minus 3/2, and then equals negative 20 plus 9/2. So go ahead, put that into the calculator, and then hit resume when you're ready for the answer. All right, you should get negative 31/2. And then our goal is going to be to solve for x, so we can go ahead and divide both sides by 2. So we get x minus 3/2 squared. And when you put negative 31/2 divided by 2 in the calculator, you get negative 31/4. And then remember, to get x by itself, we have to take the square root of both sides. So we'll have x minus 3/2 equals plus or minus, don't forget to pop out the I, the square root of 31/4. Now remember, when we take the square root of a fraction, we take the square root of the top, so rad 31, and the square root of the bottom, which is rad 4. Now rad 4 can reduce to 2. So we have x minus 3/2 equals plus or minus I rad 31 all over 2. And then the last step is just going to be to add the 3/2 to both sides. So we get x equals 3/2 plus or minus I rad 31 all over 2. Now just know that can be written as 3 plus or minus I rad 31 all over 1 singular 2. So this is a possible answer, and this is a possible answer. They both mean the same exact thing. All right, so for problems 1 and 2 down here, these are just more problems to practice. You absolutely don't have to do them, but if you'd like to, I think it would be helpful to try to make sure you master the skill. But if you have any questions, now is a good time to jot them down and make sure you ask us in class tomorrow. All right, have a good night.